Good day, Captain Philip and Alquino, to our classmates, and to anyone who could be viewing this right now. My name is Decadet Bagin John Dave, and alongside me is Decadet Dave Anthony Baliosos, Decadet Manuel Earl Buenafe, and Decadet Francis Rigi Bongoyan. We are the Group 2, and we are tasked to discuss about mooring operation. Let's begin. So first, what is mooring operation? Mooring operation is one of the most important tasks that seafarers have to perform on a ship's deck. Working on a ship's deck is not an easy task. Deck crew has to consider various safety precautions and understand working of deck machinery and systems, along with cargo operation equipments. Mooring is a procedure to anchor the ship to a fixed or floating element and keep it connected during loading or unloading operations. Safe mooring must withstand several forces, such as the wind, the current, the tide, and waves. Next slide, please. Case study: a mooring line failure on board. So this is a sample situation which has happened before. So a large LNG carrier was docked in an LNG terminal in UK, or in the United Kingdom. The 345.30 meter LOA carrier was moored with a total number of 20 lines, high modulus polyethylene ropes, following the 32324 and the aft rule. The vessel had 22 lines on board, as per manufacturer's requirements, to be used during mooring operations of 44 diameter steel light superline extra high modulus polyethylene, or HMPE, with a specified minimum braking load of 137 T. Next slide, please. So what happened? So this is what happened. While the vessel was moored, a line parted and injured the third officer, who suffered severe injuries. So the prevailing wind was reaching max strength with extent gusts. One of the four spring lines parted due to tensile overload, even though the load being applied to the line at the time was less than a quarter of its specified minimum braking load. Next slide. So the following slides and so on are to be discussed by Decadet Anthony Boliosos and the rest of the members.
Thank you for that, Decadet Bagin. Now let me proceed to my part. But why the rope parted despite the monitoring and inspections made by the company requirements? As the official investigation concluded, the arrangement of mooring decks on board contributed significantly to the rope's loss of strength and the officer being injured. The mooring lines used on board vessel and similar vessels on the same fleet were not suitable for the application, and the primary influences on rope degradation and failure modes were not fully understood by the user. Close visual examination of the break side identified that the yarn fibers had suffered localized fusing and hardening, and that the failure had been caused by tensile overload. Away from the break side, the rope appeared to be in generally good condition. In this picture, you can see the defective rope yarn kings that is being used. A technical company authorized to provide failure analysis based on the broken line samples. The outcome of this analysis after investigation and laboratory measurements was that the inner part of jack rope 3 strands revealed that yarn kings which were effective to failure. In addition to the accident, the painting of the snapback areas had also contributed to the accident. As per previous best practice guidance, areas near mooring points should be marked for snapback hazard. However, this practice created a false sense of safety in the case of the seafarer was not on or next to yellow mark area, considering that the reaction of a broken line under tension practically is unknown and difficult to be predicted. Such marking of danger areas is not actually a safety practice. So this slide will be reported by my fellow groupmate, Cadet Francis Reggie Bunguya.
Thank you for that wonderful information, Cadet Bolyozos. A lesson learned in this topic. So, the OCIMF guidance for mooring was revised to MAG4 in order to address similar issues. New definitions were introduced and new guidance was provided in respect of purchasing, using, inspecting, and retiring mooring lines. Next is the practice regarding snapback zone was also revised. The markings on deck were removed and replaced with the generic warning that all mooring decks are subject to snapback hazard. So we can see that the MH4 before. And next is the effective procedures are now required to be enforced on board vessels in order to minimize incidents during mooring operations. A comprehensive and detailed risk assessment should be undertaken prior conducting such operations. Next is an effective toolbox meeting is to be conducted also in order to provide guidance on the established mooring plan taking into consideration vessels arrangements and equipment, terminal or port arrangements, and prevailing and predicted environmental conditions. Lastly, is all mooring stations should be under the control and monitoring of competent officer who should use a stop work procedure or authorization in order to protect fellow seafarers and vessels equipment from unpleasant situations during mooring. Next, please. So, mooring equipment's guidelines, updates, and new terms. So, in July 2018, OCIMF issued the 4th edition of its mooring equipment guidelines, MEG4, to update related guidelines and include new chapter on human factor in mooring design, jetty design and fittings, shipshore and interface, and alternative technologies. For the next reporter, Cadet Benafe will report the new terminology introduced. Thank you.
Thank you for that, Cadet Bongoyan. So here, our last topic is about the new terminology. So first, we have the ship design minimum breaking load, or the MBL. So it is the minimum breaking load of new dry mooring lines for which a ship's mooring system is designed to meet Oil Companies International Marine Forum, or the OCIMF Standard Environmental Criteria Restraints requirements. So, the ship design MBL is the core parameter against which all the other components of a ship's mooring systems are sized and designed with defined tolerances. So, the nylon or the polyamide mooring lines should be specified as brake-tested wet because nylon lines change strength characteristics once exposed to water and generally do not fully dry to the original construction state. So the next one is the line design brake force, or the LDBF. So the LDBF is the minimum force that a new dry splice mooring lines will break at when tested according to Appendix B of Mooring Equipment Guidelines, or the MEG4. So this is for all mooring lines and tail materials except those manufactured from nylon, which is tested wet and spliced. This value is declared by the manufacturer on each line's mooring line certificate and is stated on the manufacturer's line data sheet. So in addition to that, as stated in Appendix B, the LDBF of a line should be 100 to 105% of the ship design minimum breaking load, or the MBL, when selecting lines, because nylon mooring lines alter strength property when exposed to water and not fully dry to the original manufacturing condition. So next, please. So the working load limit, or the WLL. This is the maximum load that a mooring line should be subjected to in operational service, calculated from the standard environmental criteria. The WLL is expressed as a percentage of ship design MBL and should be used as a limiting value in both ship design and operational mooring analysis. During operation, the WLL should not be exceeded. So the specific definition for the working load limit is the maximum mass or force which a product is authorized to support in general service when the pull is applied in line, unless noted otherwise with respect to the certain line of the product. Next is the line management plan. or the LMP. It is used to manage the operation and retirement of mooring lines and tails. The LMP also documents the requirements, assumptions, and elevation methods used in determining the line requirement criteria. So the LMP contains the ship's operator's requirements for the management of mooring lines, maintenance, inspections, and retirement during the operational phase of the mooring line life cycle. The LMP can be a standalone tool or it may be integrated into existing safety or maintenance management systems. A mooring line management plan covering all mooring ropes and wires in use, including ancillary equipment like mooring line tails and joining shackles. And lastly, the Mooring System Management Plan or the MSMP. This is ship-specific and complements the ship's safety management system. Through a goal-based approach, core elements of the mooring system are identified against which high-level goals are established, supported by more detailed functional requirements. The MSMP should be written to ensure the mooring system is inspected, maintained, and operated in accordance with the original design basis. The information contained should be available to anyone who needs to review it. So remember that the MSMP does not need to be a comprehensive plan incorporating all information. Instead, it could be a framework document that links to the information held elsewhere in the ship's records or safety management system or the SMS. So next, please. So that concludes our report about mooring operation. Thank you very much for listening and may God bless us all.